Let's start with the very important topic, that is subquery in SQL and PostgreSQL. So, by result type, we can divide the subquery into the three different categories, that is scalar subquery, row subquery, and table subquery. And by dependency, we can say we can classify the subquery in the two different categories, that is a non-correlated subquery and correlated subquery. So we will understand all of this one by one in few minutes. So let's see where we can define or where we can write the subquery. So this is the locations or clauses in which we can write the subquery. That is in the select clause, in the from clause, in the join clause, then where clause. In that comparison, in the where clause, again we can write the subquery with the comparison operators as well as with the logical operators. So comparison operators are like less than, greater than, equal to, then not equal to, greater than, equal to, or less than equal to. And logical operators like in, any, all, and exist. Now what? Now see what is a scalar subquery. So scalar subquery. So if the result will give only single value uh, after executing the query, that is known as a scalar subquery. Now if the result of the query will give multiple rows but a single column, then that is known as a row subquery, which is written over here, right? Result by result type. So that is row subquery. And if the result will give multiple columns like this and multiple rows, then it will known as a table subquery, right? Now let's understand by writing the subqueries. So now this is an example of the scalar subquery. So I have a orders table. So let me open the Excel file as well. See, I have the and let me copy the data of orders table. Select star from sales dot orders. Now let me copy this data into the Excel file. Okay, I have copied the data into the Excel file. Now let's see what is the requirement. Select average salary from sales dot orders table. So if you see over here, what is the average salary? So let me check that one. The average salary will be 38, right? Which is showing over here. So this is giving me only a single value, right? This will give me only a single value, 38, right? So that is why it is known as a scalar subquery. Now row subquery. See, select customer ID from sales.orders table. We are just selecting the only one column and multiple rows. That is why it is known as row query or row query, right? Row subquery we can call, or query, because here we have not written a subquery. That is why it is known as a row query. Now see, table query means we are we are retrieving multiple column and multiple rows, order id and order date. So that is why it is known as a table query, right? Now see, subquery in the from clause. So subquery in the from clause, that is known as inline view, right? Inline view. So find the product that have a price higher than the average price of all products, right? So what is the average price, we can say. So let me, sales dot products table is there, right? So let me copy the select star from sales dot products data, and let me copy this data into the Excel file. Okay, see now what is the average price over here? Average price is 20, right? Let me do the sum. Because of only 5 values are there, I am doing it like this. 100 divided by 5, so 100 divided by 5. 20 is my average, right? 20 is my average. Now see what is the requirement. So let me copy this requirement again over here. Find the products that have a price higher than the average price of all products. So if you see over here, what is the average price that we need to consider, right? So I have over here, I have used is window function, right? Window aggregate function, so that the detailed values of product ID and price ID, price will also be with me, right? Because of I am using the window aggregate functions, right? So now our requirement is we want to find the products that have a higher price than the average price. So now select star from. Now in the from clause I have written this query. Now what is the requirement? I want to identify my price should be greater than this average price, right? My price should be greater than this average price, so that which rows will satisfy that condition. Let me show you in the Excel file. Which rows will satisfy? So this 10 is greater than 20, no. This 15 is greater than 20, no. So this 25 and 30, these two products are higher than the average price, right? These two products. So whenever I will execute this particular query, it will show me these two products. See, 25 and 30, right? So what is the product ID and price? So product ID is 104, 105 and price is 25 and 30, right? Now let's see another way. So this is the another way. Here I haven't used the window aggregate function. Here I have used the normal aggregate function. So in that particular case, what we have to do? Select star from sales dot products table. Now I have to identify the average of price. Now what is my requirement? Select star from. Now select star from this particular table where my price should be greater than this average price, right? My price should be greater than this average price. So these two again these two records are coming, right? So this is the another way we can solve the problem, and this is the first way in which I have used the windows aggregate function, and over here normal aggregate function. Now let's see the task 2. Rank customers based on their total amount of sales. Rank customers based on their total amount of sales. So now again let me copy again this data, sales dot orders data, but now this time I am doing order by customer ID, and now I am copying this data again. So I have copied this data. Let me do it quickly. Okay. Now my customer ID 123. Sorry, this one is 1. Then this is 2. My second customer ID. Then this is my third customer ID. And this is my fourth customer ID, right? Now, now I want to do the rank. So rank customers based on the total amount of sales. So now I have to calculate the sales of all these customers separately, right? So what is the sales of this one, which is 1110, right? 1110. So 1110, 1110, 1110. Now what is the sales of this one, which is 55? So 55, 55, 55. Now what is the sales of this one? 125, 125, 125, 125. And what is the sales of this one? 90, right? So now what is my first rank? My first rank should be this one, customer ID 3, and my second rank should be this one. My third rank should be this one, and my fourth rank should be this one, right? So for that purpose, I have to do, again I have to write the subquery inside the from clause. So in this is my subquery in which I have mentioned the customer ID, sum of sales, and then group by customer ID. So this will give me sales, right? This will give me sum of sales for each customer ID. But now I want to give the rank for this one. So now rank over order by total sales. Now this column I can use above this outer query, right? This is my subquery. I have given this subquery as a table, as a name T. So this is my, at then this is my table name, right? So this is my table name. Now whatever the column I have used inside this table or inside this query, I can use it in the outer query. So rank over order by total sales descending. So wherever the total sales is highest, it will give rank 1. Whenever the total sales is lowest, it will give rank 2. Means second highest, it will give rank 2. Third highest, it will give rank 3, like that. So see, so 125 it will give rank 1, 110 it will give rank 2, 90 it will give rank 3, 55 it will give rank 4, like that, right? So this is what I have shown you. 112 it will give rank 1, then this one it will give rank 2, this one it will give rank 3, and this one it will give rank 4, right? So now let's see the another task, subquery in the select clause. So we can use the subquery in the select clause as well. So let's see the task. So product IDs, product name, price, and total number of orders. So these three columns, if you see, these three columns is coming from the products table, but total number of orders will come from the orders table. So over here I have, this is just a subquery. This is a subquery, select count of star from sales dot orders. So this is how we can use the subquery in the from clause as well, right? Or sorry, subquery in the select clause as well. Now let's see subquery in the join clause. So show customer details along with their total sales. So customer details along with their total sales. So so I have particularly two tables are there, customers tables are there, and orders tables are there. And in both the tables I have a common column which is customer ID, right? So which is customer ID. Now show customer details. So this is my orders table. In the orders table I am using the customer ID and sum of sales. So this is the query I have used as in a left join, and this is a subquery, and I am joining both of these customers table and this particular table, which is table T. using the customer ID column, right? So if I execute this particular query, let me execute this query, I will get the total sales as well, which is from the sales.orders table. So this is how you can use the subquery in the join clause as well. Now let's see the another task. So all customer details in the total orders for each customer. So over here what we are doing, over here again we are doing the left join and for the orders table, and we are doing the group by customer ID we have done. So I think both of this query is almost same. Let me try to execute. Yeah, only the alias difference is there, but almost both of the query are almost the same. Let me try to execute. Okay, over here, okay, in the above query, we are finding the total sales, but over here, total orders of each customer. That is why we are not finding the total sales. We are finding the total orders for each customer. That is why in the inner query, this is my inner query, right? And in the inner query, we are counting the order. So counting the number of orders for each customer. That is why we are doing the group by customer ID. And then this particular table we are joining with the customer ID column. So this will become my one table, right? And then whatever the query is inside there, that we can display over here in the outer query. So this is my main query. This is my main query, or you can say as a outer query, and this one is my inner query, right? Now comparison operators. So subquery we can use in the comparison operator as well. Like find the products that have a price higher than the average price of all the products. So see, now what is our average price? Average price is I think 20, right? So if I execute this query, yeah, it will give me whatever the products uh, average is more than 20, or whatever the product price is more than 20. 20 means average price. So this query we have already seen above, but here is in a different way. Here we have used the subquery in the select clause, and then subquery that uh, query we have used in the comparison operator as well. Like this price greater than this entire thing, right? Price greater than this entire thing, which is actually the average price. So again it will perform the row by row, that whether the price, this particular product ID price is greater than 20. If it is not greater than 20, then it will not retrieve. But whenever it is greater than 20, it will retrieve that particular products ID details, right? Now let's see another question. So show the details of orders made by customer in Germany. So this is a simple one. Select star from show the detail of orders. So that is why we are, our main table will be the orders table and made by the customers in Germany. So where customer ID in. So this is a again a comparison operator, right? And over here we are finding select customer ID from sales.customers table where country equal to Germany. So there will be only few customers are there in the Germany, and now these 1 and 2 customer ID order details it will show, right? Now show the details of the orders made by customers not in Germany. So over here only one condition, over here we have used the in operator, over here we can use the not in operator. So only one condition will be changed, everything else will remain the same, right? Now this is a very important one. So let's see. So subquery any operator. So find female employees. So let me copy this sales.employees data first, then I will explain you. Select star from. Okay, this is my employee data. Let me copy it over here. Okay. Now find the female employees whose salary are greater than the salaries of any male employee. It means over here, see, we want to identify the female employees, right? So that will be our first condition. So select employee ID, first name, salary, or whatever column you want to retrieve from the employees table where gender equal to female and salary greater than any of the male employee salary. So see what is the 55, 65, and 90. Now what will be our answer? See, so this female employee is salary is greater than, so this is my male employee, right? This is my male employee. So and this is my female employee. Now see, now what is our question? Read it again. Find female employees whose salary are greater than the salaries of any male employee. So see, this 75,000 is greater than any means either this or this or this. So yes, it is correct. Now 55 is greater than any. No, it is not greater than any, right? It is equal to but not greater than. So only one row it will retrieve, right? Greater than any means either or. We can say that. So see, only one record it will retrieve, which is 75,000 female, whose salary is 75,000, and that too in the female gender, right? So this will retrieve. Now let's see. Find the male employees whose salary are greater than salaries of all the female employees. So this is a reverse question. See, 55,000 is greater than all the female employees? No. 65,000 is greater than all the female employees? No. So our result should be 90,000, right? This should be our result because 90,000 is greater than all the female. All the female means not the addition of the sum, but row by row we need to identify the salary of the female employee, and that row salary it should be match with the male employee salary. And if the male employee salary with greater than all of this family means over here it should be or when we are uh, matching the any, but when we are matching the all at that time it should be and, right? So it should satisfy all the conditions. So if I execute this query, my result should be Mikkel, employee ID 4 and Mikkel, right? So see employee ID 4 and Mikkel. Perfect. Now now see this is another type of the subquery which is correlated subquery. So correlated subquery which is actually dependent on the outer query result. So correlated subquery will be executed row by row for each of the outer query result, and then it will generate the data. So it is not independent. We cannot execute this inner query independently, right? We cannot execute this inner query independently. That is why it is known as the correlated subquery. So now understand the question, and it is we can say that it is worst in performance. It is worst in because it is executed row by row, right? Now see, so all customer details and the total orders for each customers using correlated subquery. So see, select star from, then again we are counting over here the number of orders, total number of orders for all the customers from the customer table, but orders are there in the orders table. So over here we are identifying the customer id from the orders table with the customer id from the customers table. So it will generate for each customer id row by row, and then it will calculate the count in the orders table. So that is why it is slow in performance. Now this is the again this is two operators are there, exist operator and not exist operator. So this is better in performance than the correlated subquery, because it is exactly checking that whether the particular rows are exist in the inner query or not. If it is exist, then it will retrieve the data. So over here what we are checking, so the details of the orders made by customers in Germany. So see, select, because detail of the orders we want, right? Detail of the orders we want. So select star from sales dot orders where exist. So it will directly exist in the customers table. Over here you can mention like anything. You can mention like one. So whether it is exist in the customers table where country equal to Germany. And again, this inner query you cannot execute independently, right? Because again it is a correlated subquery. That is why you cannot execute inner query independent, but it is still better than the correlated subquery, which does not have use the exist operator, right? And again this is the something different example for the not exist. So the details of the orders made by customers not in Germany. So only one thing we have to change, in place of exist we can write the not exist. So this is the examples of the subquery. I have documented most of the thing over here in the this particular document, and I will attach this document in the video section as well. So that's it from the subquery. We will see the another topic in the next video.